All right, so I'm going to be presenting on stoichiometry. All right, so what is stoichiometry? So stoichiometry is the skill of successfully relating the different amounts of substances in a reaction, and this applies to both reactants and products. And then when you correctly stoichiometrically balance an equation, with all the different amounts of reactants and products, the balanced chemical equation is what you have when you do that. All right, so why is stoichiometry important? So you can use stoichiometry to, for example, determine how much of a certain substance you need to yield a certain amount of another substance. And you can do this using stoichiometry and then mole ratios in the balanced equation. And, you need to know like the molar mass of the substances involved. So yeah, determining, amounts of yield of products is what stoichiometry is really good for. All right, so how do you stoichiometrically balance an equation? So the original equation, is not balanced. So the first step is to count up the number of all the atoms on the left side of the reaction, and then you count up the number of all the atoms on the right side of the reaction, and then you find basically the greatest or the least common factor of coefficients that make the number of atoms on both sides the same. And then, you can go back and check your work once you do that. All right, so here's an application problem. So given the unbalanced equation, C3H8 plus O2 yields CO2 plus H2O and the following molar masses of each of the component atoms, they're the molar masses, how much in both grams and moles of C3H8 is required to yield 10 grams of water? All right, so, step one, like we talked about, is the unbalanced equation. So we have that on the right. And then number two, you count up the number of all the atoms on the left side of the reaction. So you have 3 carbons, 8 hydrogens, and 2 oxygens. And then you count up all the atoms on the right side of the equation, where you have 1 carbon, 3 oxygens, and 2 hydrogens. So now you have to find coefficients that make the number of atoms on both sides the same. And in this case, it would be 1 for C3H8, 5 for O2, 3 for carbon dioxide, and 4 for water. And then you can, just do a little simple math to make sure the number of atoms is the same on both sides for all atoms. And then step two, getting what the problem wants you to get. You recall the balanced equation, you recall the desired amount for the product, which is 10 grams of water. You recall the unknown, which is grams and moles of C3H8. Then you convert 10 grams of hydrogen or water to moles, which is 0.556 moles of water. And then using the mole ratio from the balanced chemical equation, you can determine the moles of C3H8, which would yield 0.139 moles of C3H8. And then using the molar mass of C3H8, you can find the amount of grams that is in 0.139 moles. All right, so here are some takeaways about stoichiometry. So stoichiometry is the skill of relating different amounts of substances in a reaction. And then balanced chemical equations emerge from correct stoichiometry. And balanced chemical equations and their stoichiometric ratios can be used to determine unknown amounts of substances in a reaction. Thank you.